And you guys all were in my class last term, so same thing as last time. It will show up on Blackboard at 6 o'clock, and you get 2 hours. So it is only 2 hours. In class, it would be a 1-hour test. So it's going to be a beautiful day. You get your notes, but that does slow you down. So I would have your chart of all the shapes and stuff and things like that available. I will be on Zoom to answer questions. And when you do submit, I ask that you come to Zoom so we make sure everything's there. But I'll be on Zoom, so if you have questions or need a hint or something. And last year, when I did this test with the class, that's when I learned a lot about dishonesty. And so you guys had integrity last term, so let's just keep it up. I was flabbergasted. All right. When we are doing these, we're going to obey the octet rules. So single bond to the outsides, give your dots. Use a pencil or erasable pen. We've used 16, and then you put the rest on the center. And if you're able to obey the octet rule without double bonds, without expanding it, stay within the octet rule. Right, this has 4 clouds, and so this is a tetrahedral bent. I do want both words unless, yeah, I do want both words. Tetrahedrals are 109 degrees and SP3. And this is polar because it's bent. I then wanted you to show the net polarity that was hidden in there. On this, the test is 4 pages. So I condensed it down into 2 pages. So yeah, you have to show the bend to be able to show that. So you can either redraw it, or if you were clever like me, and so the pull is going to be towards the chlorines. Oh, I know what I was going to say earlier. Hydrogen bonds. They are traditionally NO and F. Most of the stuff out there now, since a lot of you love YouTube, chlorine is considered that it makes a hydrogen bond. I'm a biochemist, and I have trouble with that comment. So, but if you see something with that, that's fine. All right, SO3 has 24, and so on this one, when we do our octets on the outside, you've used up your 24. So we have 24. We're not done because the center doesn't have an octet. So you guys have a disadvantage since I can't monitor you. If we did this in school, if we did this in class where you all did it my way, like we did the lab in class, and so nobody was on YouTube, and we were doing the test where I could monitor you, people do better. YouTube has a lot of incorrect information on it, and so I would encourage you to use your notes, but you're not supposed to use Google and YouTube when you're taking the test. It's really obvious to know when you're getting information not from your brain, and then it doesn't put me in a good mood for the future. All right, we have to erase 2 and make a double bond. You are going to obey the octet rule when you can. You get an octet. This is a resonance. So a resonance is when you have doubles and singles. This is planar triangle. 120 sp2, and it is nonpolar. It's the same the whole way around. That's the idea of a resonance, that all those oxygens are the same. And then the next one, selenium's in the center. So one center. The only time you're going to have multiple centers is if you have 2 chlorines. So keep one center, and then we're just going to put all the chlorines around it. You give your octets. You're going to have 8 times 5, which is 40. And the extra 2 go on the center. So that's what our Lewis structures look like. This has 6 clouds, so it is an octahedral, but one of them is a lone pair. So this lone pair here is going to make it a square-based pyramid. So it's half of an octahedral. 90 degrees are our bond angles, SP3D, and it is polar. Pyramids are going to be polar because they're missing the bottom half. All right, hydrophobic means it's going to be something that's nonpolar. Back to the question, somebody's not asking, but I know several people have asked me individually. Polar, nonpolar is a really tough concept. It is probably our biggest concept this term. Nonpolar means it's symmetrical, that there's nothing pooling different. On this one, to show the pool, we'd probably have to redraw it with the chlorines down, showing the pyramid more. And so my pool is going to be pulling down away from the dots towards all the chlorines. All right, so things that are nonpolar, which was the SO3, are going to be hydrophobic. The resonance was also SO3, and then we're going to do formal charges. So it is, again, they're valence electrons minus dots plus lines. So this is where online some things are just hooked on formal charges, but the sulfur will have 6 valence electrons minus 4. And so that gives us a positive 2 for the sulfur. So there's all these hypothetical ways of making this molecule, but we're not going to go there. This oxygen would be 6 minus 6. Let's do it down here. So this was 6 minus 4, so this is plus 2. The oxygens, this would be 6 minus 6, so we get a 0. This would be 6 minus 7, so it's a minus 1. And my other oxygen, we have 6 dots in a line, so 6 minus 7, so minus 1. Does anybody remember what is not right about my final answer on that one and why? It was something that showed up on a worksheet. If it is a resonance, you need to average the oxygens. So they're all negative 2/3. That is the point of a resonance, that the formal charges of the outer ones that are the same will average. It's not a big deal, but I just wanted to remind you of that. Any questions? Right, silicon. So we have chlorine, a fluorine, another fluorine, another chlorine. This is why I'll be on Zoom, because sometimes people read these funny and think it's a carbon and 2 iodines. That's 32. This is a tetrahedral. I did not ask for that, but there are no isomers. For a tetrahedral, there's only going to be one way to draw it. It is polar. Even if you drew the fluorines across from each other in a tetrahedral, the only way a tetrahedral can be nonpolar is if it's all the same the whole way around. So if it was chlorines the whole way around, I don't know if, I do have it. So that's this guy. The green ones are the chlorines. There's no way to put the chlorines across from each other in the actual molecule. So a tetrahedral, we're not going to have isomers. Moving the chlorine to here is still the same thing. We didn't make something new. Right, this one has isomers. This is the one you have to draw it where you can see how things are laid out. Oh, I did that wrong, sorry. There's 3 fluorines. All right. And that gives us 40. So this is my triangle. This is polar. This is the one where there was actually 3 ways you could do it. So you could also put, so all 3 fluorines were in the triangle and the chlorines were across from each other. So in my triangle, this would be nonpolar. Or you could put 2 fluorines in the triangle and 1 chlorine in the triangle. So I'm trying to show the triangle like that. And that one is definitely polar. Questions? Okay. So we have an atom, so we can just call it A. It has 1 lone pair and then 3 atoms around it. So you can just call them X. So what is it? Well, that looks like a
Tetrahedral.
Yeah, it's a tetrahedral and then a triangle pyramid. So molecular geometry is actually referring to the triangle pyramid. If you're not sure, you can always come to Zoom and ask what I'm referring to, or just put both in there and we're good. A reminder with pyramids, we should say if it's a square base or a triangle base. Hybridization is sp3, that comes from the tetrahedral. Bond angle would be 109, and it's going to be polar because it's a pyramid. So questions on the first page. And again, I scrunched everything in. You do go back over your study sets. Go back to your 4 study sets. Look over the 2 labs and get your stuff in. If you have any late assignments, and then just stay caught up from here on out so you don't have to do this mad crunch at the end. Most of you have gotten stuff in, so just get it all in. All right. I wanted to go through this again. We talked about it. What is the difference? And this is the most missed question that has always been on the test. That students want to say a sigma bond is a single bond and a pi bond is a double bond. Because when we count them, that's how we go about counting. That's not actually what the difference is. Does anybody remember?
Sigma bond is between, and the pi bond is above and below.
Yeah, and there's one more key thing that Damon and all of you would add is it has to do with an overlap. So it's an orbital overlap between, and it's between the nuclei. So that's a sigma bond. So the overlap, if that's our nuclei, is in the area between the nuclei. So we're in this area is where the electron's potential is. In a pi bond, the orbital overlap is above, below, in front, behind. Another thing, and I mentioned this on, it was the last question, I think, on the homework. Pi bonds are made by unhybridized, they are made by p orbitals. Even in this molecular orbital, when s's overlap, you can only make sigma. Pi bonds come from p orbitals. You can also get sigma from p orbitals, that's the x-axis, but pi bonds are made from unhybridized p orbitals. I don't think I mentioned that last week, but we'll add it there. All right, number 6. so the pi bonds, the thing that's nice on this, oh no, this one did not show all the hydrogens. So that's why I picked this picture. Down here in the ring, every carbon has to make 4 bonds. So this carbon at the top of our hexagon has 4. This one needs a hydrogen. That one we need a hydrogen. That one needs a hydrogen because it's only showing 3 bonds. That needs a hydrogen. That needs a hydrogen. That was the very last page of your lab. You had to draw, some of them are missing hydrogens. So, all right, you had to draw them in. I got 23 and 4. Pretty sure you all got the pi bonds because it shows 4 double bonds, but there are 23. That OH, that H is also a bond. Did anybody get 23? No, I'm right.
I got 23.
Yeah, I counted a couple times, but you guys, you'll see these. Some of them will be easier. You might have one like that and just count and move on. It's 1 point. All right, the most polar. Which one? You see an OH? If you see an O or a HO, you're picking that. That guy is pulling. That's our pull. Now we're doing bond angles, and I didn't really proofread this. This is also why I will be on Zoom, because sometimes it gets reformatted, especially when you print. So most of you have printers, but if you don't have to write the questions out. You know that. You just write the answers. And so A is referring to here. That's going to be 120 degrees. B is referring to here. That is not 120. That is the nitrogen. You have to remember to add the dots to the nitrogen. B is 109. Oxygens also have dots. And then C, we will go with, so for A, I picked this one. For C, we're going to go with this. This is a tetrahedral, so it's a carbon with 4 bonds, 4 single bonds, so it's 109. And then we're going to do 1, 2, 3. So carbon number 1 is sp2. Carbon number 2 must be this guy. So that is sp3. And carbon 3 down here, it's an sp2. All the hexagon is sp2 there. And then, so the last page of that organic lab, that is actually, well, the part at the bottom where you're counting sigma and pi, actually your worksheets have had enough practice of that too. Hydrophilic and hydrophobic. I am going to say, oh, this is not a good question, but I would accept either answer depending on your explanation would be the key. I'm going to go with hydrophobic and say there's too many carbons. Just because I know this one is hydrophobic. There's just too many carbons. And all the carbons are down here in one big lump. If you said it was hydrophilic, it was a question some of you have asked. The general rule is a 6-to-1 ratio, and so you could say, well, the oxygen and nitrogens, so you have the OH and the NH are going to pool. But there are just too many carbons in one area. I try to pick ones that are not going to be that dilemma. And if it was, I would, same like on the lab, some of them I would have accepted either one. So theobromine, I said was hydrophilic because it had so many nitrogens on it. And somebody Googled it and it was hydrophobic. Theobromine is a molecule in chocolate that makes chocolate so amazingly therapeutic. All right. So you will have, this is our one math problem. we are going to make pictures. So this is 2 carbons and, oh wow, I did it wrong. Sorry. Don't draw what I'm doing. The only way this will work out is you'll have to have a double bond between the carbons. Carbons make 4 bonds. And so if you only have 2 hydrogens for each one, water is just water. And this is saying we have a C with 3 H's, another C with 2 H's, and then an O and an H. So we're going to be doing the math thing in a moment. So I want to go back and refresh on the study sets. You'll be done. You'll be done by this time on Thursday and you get to go. You go, yay, I'm done. All right. Does the hybridization change? Yes. This is sp2, this carbon, and we end up at sp3. Does anybody remember the formula we're going to use for part B? So you want to have everything nicely organized. Bonds broken minus bonds formed. And just real quick, if you get stuck, please come on to Zoom. Please come on earlier than later, because as people start turning in, it gets harder to come in and ask questions. But if you get stuck, I mean, you can move on and finish and then come, or you can just come and say, yeah. And just be patient if you're in the waiting room, because I only let one person in at a time, unless as people are just turning in their test. All right, so we're going to make a list. Here we have 4 carbon-hydrogen bonds. We have a carbon-carbon double bond, right? That's all our bonds there. And we have 2 oxygen-hydrogen bonds. And then we're going to subtract. So those are all my bonds broken. My bonds formed, I have 5 carbon-hydrogen bonds. So we'll reduce in a minute, but let's count all our bonds. I have a carbon-carbon bond. I have a carbon-oxygen bond. And I have an oxygen-hydrogen bond. So those are all the bonds that are going to be formed. So questions about that? You have to make a picture. It's really not that bad. All right, we're going to reduce. So we really didn't break these 4 bonds. We just made one new one. So we can ignore those 4 and just do 1 here. Same with the OH. We lost one of them, but one of them we kept, so we can ignore this one and reduce this to 1. And that will make our math a lot easier. Yeah, so go ahead and fill in your numbers. So the carbon-carbon is 600 kilojoules. If you write it out and then you put the numbers right underneath, I'm okay with that. My OH or HO is 450. Show a unit, kilojoules. So these are my bonds broken. So traditionally, this was always done in class, and they weren't allowed a calculator. They weren't allowed any electronics. They had to learn their Lewis structures, and they could do it all really fast. I think you guys have a huge disadvantage. So I always made these numbers that you could do without having to use your calculator. So 600 plus 450, and then we're subtracting. Our carbon-hydrogen bond is 400. The carbon-carbon bond is 350, and the carbon-oxygen is another 350. So 350 is 700 plus 400. So we have minus 1,100 kilojoules. All right. I forgot my units. That's okay. We can go and put them back in there. So again, if you line it up so I can see, you've listed your bonds broken and formed, and then we just subtract. So I got a negative 50 kilojoules. All right, and then molecular orbital. Again, the first page is all molecular orbitals. It's not quite as crazy as your study set, had just too many things on there. So you're gonna make one sketch, count your electrons. So like on your worksheet today, that will be like the top half of it, and you'll do one of them. So our carbon, our oxygen, so 2, 4, 6, 8, 10. So this is my CO diagram. I do look that they're labeled, and so again, a couple things lower and higher than the starting point. And the labels, sigma is the one line, the two lines are pi's. The ones that end up higher get a star because they're antibonding. And all these up here get the subscript 2p because it's the 2p orbitals that are overlapping. Down here, it's a 2s because it's the 2s orbitals that are overlapping. All right, so the bond order is 3. There's 1 sigma and 2 pi. So that's every 2 electrons. So 2 electrons equals 1 bond. So if you have 2 electrons, that's a full bond. And so this is diamagnetic. And the highest occupied is the sigma 2p. We don't flip the diagram. Don't flip the diagram. I'm not going to ask about that. It's all a theoretical thing, and then students get all their answers wrong. So just keep it this way. Same with on your worksheet. You don't want to flip it. So positive means we will lose 1. So we would erase 1. So we would now have only 2.5. We have half a sigma. We still have the 2 pi's. This is paramagnetic. Sigma 2p. So to do the stronger and longer, it's always comparing the two. So you can only do this. This is a comparison. Same with the worksheet from last Thursday, worksheet 3. That was a comparison of the different molecules that you drew. So we'll get done early today. So if you have questions on any, I'll be here the hour before the test. So if you have questions on any of the worksheets or study sets that you want to go over, the stronger one is the higher bond order. So again, higher bond order is stronger and shorter. 3 is the highest, means we have a triple bond. So the CO is the stronger, the CO plus is the longer. Does it exist? Yes, they both exist. When would this be a no? You do get a no on your worksheet.
When it's all filled out, both
Yeah, everything, when you get a bond order of 0. So either this part is the only thing and you have nothing up here, or it's all the way filled. All right, got one more question. So if we added an electron to CO, so we went to CO negative, that would mean we have 11 electrons. That means we're filling in the antibonding. What happens to the bond length? So does it increase, decrease, or stays the same?
Would it be the same?
It does change. Christian, what'd you say?
Increase?
It decreases. It has to do with at CO we had, oh, I'm sorry, the bond length. You were right. You said increase. The bond length increases. So it is increased. As we add or take away from the 3, 3 is the highest number we can get. So if we're going to add or take away, it's going to make it longer and weaker. So you'll see questions, you know, like on the study set today, I can find it. You'll see questions like this that are fill in the blank, but they're only going to ask about one of them. They would say, is NO paramagnetic or diamagnetic? And so you would just count your electrons, and or you can even fill them in. So, you know, I went through this pretty fast. You guys get 2 hours, so you should be fine. Just study, just be prepared, and enjoy the sunshine. Any questions? All right.